Okay, last problem in 2-3. Find the domain of each function, and remember, the easiest way to think about domain is domain restrictions. So with A, we need to be concerned about division by 0. If x is -2, then we have divide by 0, and that is a domain restriction. And by the way, if it's not obvious that x has to be equal to -2, all you have to do is set that expression equal to 0, because that's the bad thing, 0 in the denominator, and then just solve. So this leads to the domain restriction, x cannot be equal to -2. So on B, here's what we're worried about with square root. That, once we do our calculations, that number needs to be 0 or greater. It needs to be a positive number or greater than 0. So the way we work around this is to just set up an inequality. -4 minus x has to be greater than or equal to 0. And we're going to solve this. But when we multiply by -1, we have to change the direction of the inequality. It's just that one picky little rule about solving inequalities versus equations. When we do that, we get x has to be less than or equal to, whoops, error there, -4. Okay, so when you think about it, x can be -5, -6. If we plug a -5 into this square root, we will definitely get a positive under the square root. If we plug, say, a number that's greater than -4, let's say -3, we get -4 minus a -3, which gives us a negative under the square root. So you can see that this is our domain. Okay, last one I wanted to show you because it's a trick question. So we're concerned about that being equal to 0. When you set that equal to 0 and solve it, we get x squared is equal to -3. As soon as we take that square root, that is a non-real answer. So it turns out when you have a squared and anything added, it's always all real. Now I'm not sure how our XYZ homework does it, but when we write it, we can write it like that. Probably have to put it in interval notation, that every number will work for that one. All right, I will see you in class.